Now we are going to discuss about the generation of three-phase AC voltages. Now in this three-phase AC voltages, just now we discussed about the single-phase AC voltage. So in a three-phase AC voltage, here three coils are there. What do you mean phase? Phase means a winding or a coil. Here how many phases are there? Three phases. So that's why first of all I will show where are the three phases. Now here I will start from one phase. This is a one coil, that is the entering path is here, leaving path is here. So that's why now I will consider this as an R and R dash, R dash. Okay. Next, coming to the second phase. Where is the second phase means? So since it is a three phase, three windings are to be placed here. So each winding will subtend by an angle of 120 degrees apart. So that's why here now this is an R phase, that is the first phase. Whereas the second phase means I will taken from here, from up to this, from this is a 120 degrees apart. It means that here I will taken, okay, and the return path for this I will taken here. So that's why here there is a one more coil. Now I will call that coil as a Y and Y dash. Okay. So now observe here the angle between these two here. So here I will consider this as an R. Now where is the Y? It is 120 degrees apart. 120 degrees apart. Next, what about the third phase means? Here from the Y it is 120 degrees apart. It means that here, so here I will take one more coil. This is a B, I will consider B, and the return path for this B is here B dash. So that's why here the angle here it is one more 120. Okay, automatically the angle from this R here also 120 degrees is there. Okay, so it means that the three coils are there, so that's why you called it as a three-phase machine. Since it is used for generation of AC voltage, we call this as a three-phase generator. So now we arranged the coils in this stator. Now coming to the rotor, here a single rotor is there. Here now I consider this is your north pole and here is your south pole. This is the south pole of the rotor. Now the rotor starts to rotate in the anti-clockwise direction like this. Now similarly, from the last explanation, here the north pole has the flux coming from the north pole, and here south pole have the flux here like this. Now when the rotor rotates in the anti-clockwise direction, the R phase voltage has maximum when north pole reaches to here and south pole reaches to here. Okay, in the same manner as I said for the single phase AC voltage, here also three phase AC voltage will come. Now this explanation I given by means of tracing the waveform. So now here the waveform here I am showing here. This is the y axis. Similarly, I am tracing out the three phase AC voltages now. Now this is the graph I am showing. This is the graph. Now before going to draw the AC waveform, it's very easy to make this as a three waveforms by means of drawing this triangular symbols are there. Each are subtended by an angle of 120 degrees. So that's why first of all R phase voltage I am tracing out. So now see here, this is a R, so that's why I am drawing this red color sketch. This is the R phase voltage. So now here the R phase voltage, now I am drawing here. So this is the R phase voltage. This is the R phase voltage. Okay, like this it is coming. Okay, this is an R phase voltage. Now what about the Y phase voltage? Y phase voltage will start after 120 degrees. So that's why here this Y phase voltage I am showing here. Now here angle subtended here I am showing now. This is your 0, and here is your at this angle this is your pi by 3, that is 60 degrees, and now this is your uh, 2 pi by 3, that is 120 degrees, and here is your, this is a pi for this waveform, and next one one more uh, pi by 3, that is 4 pi by 3, and here this is a 5 pi by 3, and this is 2 pi. Okay, this is the 2 pi. Here I am showing 2 pi, and this is 7 pi by 3, 7 pi by 3, and this is 8 pi by 3, 8 pi by 3, like this. Okay, now this is about the R phase waveform. Now I will draw the Y phase waveform. Now this Y is like this Y color sketch I am using here. This is a, yeah, Y phase voltage. The Y phase voltage will start at 120 degrees apart, so that's why here this is a 120. From here uh, to this is Y phase voltage, this is a Y phase voltage. Okay, now from here this is the negative cycle of this Y phase. So like this Y phase waveform will be there. So that's why you observe here, so how much angle is there between these two waveforms means here 120 degrees apart. Clear? Next, where is the B phase waveform? The B phase waveform will start after this Y one more 120 degrees. That's why here it will start. Here it will start. So this is the blue color I am representing now. This is a blue color waveform. So like this the B phase waveform I am showing now. Like this it will continue. Now the previous cycle, say here from this Y waveform, here one more 120 degrees is there. So if you taken from the R phase, it is totally 240 degrees. From the R phase, the B waveform will start at 240 degrees. So that's why this is a way. Now the same waveform now I am tracing out here also, this Y phase waveform. Like this, and the B phase waveform will represent like this. Okay, the B phase waveform will represent like this. So this is the R phase and Y phase and B phase. So now I represent here, this is your E suffix R phase voltage waveform, and this is your E suffix Y, and this is your E suffix B. Okay, this is the Y axis, this is the induced EMF magnitudes. So this is the way the waveforms will generate. Now I want to represent in a circuit point of view how I want to represent the waveforms. So since here three phases are there, so now three coils are there here. So that's why the three coils, this is a R phase coil, this is a R dash, and this Y and Y dash. Now this is a B and B dash. Now I want to represent in a voltage source like, so that's why just now I saw here the the single, in the case of single phase AC voltage, in the case of single phase voltage AC voltage, how I represented from this coil side to this circuit point of view. Here also in the three phase also, now I want to show it in a voltage sources. A single phase three phase generator means here three single phase generators are there, three single phase generators are there. So that's why now how these three coils can be arranged in a three phase machine, how those three coils can be connected. So here there is a two types of connections are there. One is a star connection, okay, and a delta connection, delta connection, delta connection. So in a star connection, how these three coils are there means, these three coils can be arranged like a star fashion. This is a R dash, and this Y is 120 degrees apart. So that's why this Y coil, so here is a beginning terminal and this Y dash is the ending terminal. The ending terminal of this Y coil is connected to the ending terminal of the R dash, and here this is a B and B dash. So all these ending terminals are connected at one point. Now the beginning terminals are connected to the any load like this. This is a star connection. Now we will discuss later uh, coming to this connections. Now coming to the delta connection, it is just like a three phase winding is connected in the form of delta fashion like this. Okay, now the three terminals will bring together. Now here is an R dash, and Y dash. Sorry, this is Y dash. This is a Y dash, and this is the B dash. Now here is a R terminal, and this is a B terminal, and this is a Y terminal, Y phase. So like this a star connection and delta connection, two connections will be there in a three phase machine. Okay.